Hello friends, Namaskar, Jai Shri Ram. In today's lecture, which is lecture number 16, we shall discuss about phase control rectifier, which is especially regarding inductive load. Previous lecture I discussed about the RL load. Now let us discuss about pure inductive load. As you can see here in this particular circuit diagram, there is a thyristor and connected in series with pure inductance. Okay, and there is a pure sinusoidal supply given to the circuit and all these notations means the polarity of current and voltage, all these are given in the red pen. Okay, now what we can understand here is that what is the alpha, what is gamma t, and what is beta. Alpha means firing angle, gamma t means conduction angle of thyristor, and beta is extension angle. So let us discuss one by one. Now see, this particular circuit is very much similar to RL load, except that R is absent. Means in that case the gamma t, which is conduction angle of thyristor, is pi minus alpha into 2. Okay, and similarly extension angle is also 2 pi minus alpha. Okay, now we have to calculate the value of load current. Now for finding out the load current, what shall we do? We shall discuss about the KVL. Okay, if you see the circuit diagram in which we just apply the KVL says that LD dt of I naught is equal to Vm sin omega t, as you can see here. So this gives me the value of I naught, which is equal to Vm upon omega L minus cos omega t plus k. K is a constant. We have already discussed about the calculation of k in much detail in regarding previous videos. Now besides this, basically the waveform contains 5 different diagrams. So number one is the supply voltage waveform, which is pure sinusoidal. The next one is gate pulse, okay, which is given periodically, means in first half, positive half, this is at angle alpha, you can see here, and then in the next cycle 2 pi plus alpha. So there is another pulse. So in positive half only, because this is a phase control rectifier in half wave. Now third waveform is regarding this V naught. V naught is basically the output voltage. As you can see here, the V naught is symmetrical about x-axis, which is omega t axis. So obviously this pure inductance case, since this is a pure inductance case, we can say that the average output voltage comes out to be 0, because the positive half is exactly equal to negative half. So that is the case for average voltage of pure inductive circuit, which is always 0. Okay, as we had seen in case of the pure diode also. Now next circuit, or sorry, next waveform is I naught, which is load current or output current. This load current is shown for a particular firing angle. So as you can see here, this is starting at 30 degree and terminating at 380 degree. How is it possible? Let us see this. Now for calculating the initial conditions, as we have already discussed, initial conditions are basically nothing but calculating the value of k. So how to calculate the value of k? As you can see here, the I naught is equal to 0 at omega t is equal to alpha, as you can see from this particular waveform diagram. See this diagram, at L omega t is equal to alpha, I naught is equal to 0. So just put this value in the respective equations. So this becomes 0 is equal to Vm upon omega L minus cos alpha plus k. So from this you can get the value of k is equal to Vm upon omega L into cos alpha. So finally this would get me the value of I naught, which is Vm upon omega L cos alpha minus cos omega t. So this is an important expression for calculating the value of load current. Now I naught is peak at omega t is equal to pi, as you can see from this expression, and this is also obvious from this wave diagram. देखिए ये in this particular diagram ये आप यहाँ से देख सकते हैं, so that this at omega t is equal to pi, I naught is at peak value, which is the maximum value, and V naught is equal to 0. जैसा कि मैंने आपको बताया कि V naught is also 0, because this is pure inductive circuit, the average output voltage is 0. Next, this is now complete waveform diagram, as we have already discussed. This is pure sine wave, then gate pulse, etc. And now this is omega t. In this particular last waveform, you can see easily this is omega t, sorry, gamma t. Gamma t is basically the conduction angle of the device, which is thyristor in this case. So thyristor would be on for a particular period, which is gamma t. तो gamma t देखिए यहाँ से शुरू हो रहा है, जहाँ से ये फायरिंग एंगल आपका ये स्टार्ट हो रहा है ओमेगा अल्फा से, और ये नेक्स्ट उस तक जाएगा, है ना, जहाँ तक ये करंट आपका जीरो हो जाता है. तो एट दिस बीटा दिस करंट बिकम्स जीरो. तो दिस इज कॉल्ड एक्सटेंशन एंगल. For example, if alpha is equal to 30 degree, then beta is equal to 380 degree. Okay, so this is about the waveforms. And now we can see another way to explain this particular circuit with the help of an example. Now let us see this. This is an example of again pure inductive circuit in which I am showing a diode in series with the switch and pure inductive circuit, and this in switch is connected in series with the diode and having a time of 2.5 millisecond, means the switch is on at t is equal to 2.5 millisecond, means this combination itself is nothing but a thyristor. Okay, a diode in series with the switch is nothing but equivalent to a thyristor with a firing angle of equivalent value of 2.5 millisecond. How is it possible? Let us see. Vs is equal to 100 sin omega t volts, omega is equal to 100 pi radian per second, and L is equal to 31.83 millihenry. This is given in the question. Now the question is, initial value of the inductor current is 0. Switch as is closed at 2.5 millisecond after positive 0 crossing of the source voltage, as I just told you. Now the peak value of the inductor IL you have to calculate, means you have to calculate the value of load current, or you can say the inductor current you have to calculate after 2.5 millisecond. So how to calculate this? This is simple. You can see this, the I naught is equal to Vm upon omega L cos alpha minus cos omega t, as we had seen just now. Alpha is equal to pi by 4 because alpha is equal to pi. How this alpha is equal to pi by 4? You can see from earlier slide where we had switched on the circuit at 2.5 millisecond, so that is equivalent to alpha is equal to pi by 4. So I naught is peak at omega is equal to pi, as we had discussed right now. So I naught peak is equal to, see this Vm, you just put the values ये in expression में आप रख दीजिए, तो you are getting the I naught P is equal to 100 upon 100 into pi, because omega is equal to 50. तो sorry, f is equal to 50, then omega is equal to 100 into pi into 31.83. okay, L की वैल्यू यहाँ पर रख दी है, and in bracket alpha is pi by 4, means cos pi by 4 is 1 upon root 2 प्लस ओमेगा टी इज पाई. ओके, तो cos पाई इज -1, तो माइनस माइनस ये प्लस हो जाएगा, सो दैट यू आर गेटिंग 1 upon root 2 plus 1. So finally you are getting 17.01 ampere. So this is the current flowing through the inductance, which is the peak current. Okay, so this is about today's lecture. Now in the next lecture I will be discussing about other types of circuit. So thank you for watching my video, and have a good day. We shall meet you earlier in this. Thank you. Jai Shri Ram.